This one's what we call a screw cutting one, and that's a trainer. The difference is that on this one you have a screw thread under this cover. If you peel that back, you can see there's a cover in there, and there's a screw thread in there. And that gives motion from the motor system to the bed here, so we've got automatic feeds. And the idea is that it gives you screw cutting capability to make threads and things. Not that we ever use that with school, but it does give you automatic feed to give a nice finish. The basic components, this part is called the headstock, and this part is the tailstock. The work is held in a chuck, and there's two chucks that we can use. There's a 3-jaw, which centres like a normal chuck, like in a drill, and we can have a 4-jaw independent chuck, so we can put in odd shapes of work, or put pieces of work off-centre, so you can actually swing it off-centre. So why you might do that, this is something I made a few years ago. This cam on there, for example, is turned on the lathe. By setting it off-centre and then turning it, it gives you that cam effect. So this was actually made on this lathe, and a machine that I haven't got here, a grinding machine, but that was made here. So, headstock, the tailstock. This part is called the bed, and on the bed we have on the top part here these rails, and on the rails runs this carriage, so the carriage runs along the rails. We move the carriage back and forth using this here, which is called the hand traverse wheel, and that moves it back and forth. And then we've got a cross slide, which we use for this here, and then we've got a top slide here, or compound slide as it's sometimes called. And it's called a compound slide because we can actually change the angle. It's not fixed. We can slacken this off here and change its angle. On top of the compound slide we've got a tool post, and in the tool post we've got a tool holder, and in the tool holder there's the tool. This is a quick release system on this one, which is very useful, so I can take the tool bit out and swap it to other sorts. So rather than having to unscrew and take it out, we've got the quick release system. So that just allows us to change the tool bits very quickly. The important thing in setting up is making sure that the tool is at the right height. If you imagine as the work's turning, we've got to have the tool the right height. If it's too high, it's going to miss the centre, and if it's too low, the work might try and climb up on top of it. So the critical thing is getting the height of the tool, and we do that by slackening this off and adjusting this wheel up and down and checking that against the centre of the work. It takes a little bit of fine adjustment till you get it right. Once it's right, it's then okay set up for the work. The whole post can also swivel, so we can point the cutting tip at whichever surface we're working at. So if I'm going to what we call face off, like smooth the edge of it, then we want the cutting edge to be against that surface. So if I now take the piece of work out, here's the saw cut edge at the moment, so if we put that in, and lock that tight, and then remember to take that chucky out, because if that's left in then you start it up, thing flying across the room. Used to be a favourite of people years ago. The guard comes down, and it will not start without the guard. If that's up, nothing happens. So the guard has to be down before you can start the machine up. On the front here, all these gears and all this gearbox selector are there to allow you to change the speeds of the feed to give you different screw thread pitches. Ignore all that, you don't need to know any of that. The only thing that's important are these two, which control the speed of the actual chuck. There's lower and higher positions, and then we've got 3 positions here, so it goes anything from 43 right up to 1,000. So to change the gears, it's not like a gearbox in a car with a synchro mesh. You have to carefully adjust the gears. So you push the lever in, and then rock this back and forth to get the gears to align. And if I push that one in and there, so this for example now is 43. So if I start it up so you can see 43 RPM, very, very slow. I can stop that with a foot switch if I need to. If I then take it up to say 150, just so you can see the difference. Again I can stop it with a foot switch or the mushroom button up to 512, which is probably the most commonly used speed, is that speed there. Then I can switch it off. If it's running and someone picks up the guard, that will stop it as well. So it can't run without the guard being down. So we've got the work mounted in the chuck, we've got the tool set the right height. Now what we're going to do is take a skim off the surface to get that end flat. The movement of this takes it across to the work, and then this feeds it across the surface. To get a good finish, this needs to be moved as smoothly as you can, and not to dig it into the work, or dig it in and then try and start it. Wait till it's running and then feed it in gently. When you see them used commercially, they feed a fluid on here to keep the tip cool, and they can take massive amounts out in one go, but in school generally take them little skims at a time. It's used more nowadays by sixth form really than anybody else, so it's usually one-on-one, give them a hand and then they have a go with it. It's not used very much at Key Stage 4.
It's used by some students who make components on it. Depends on the nature of their projects. It was used a couple of times this year.
Okay, so the guard's down, the work's held securely. I've got the tool close to the surface but it's not touching it. I can then start up the machine. Now what I'm going to do is move the carriage over till it just touches the surface, and when it's touching the surface, feed this gradually across the surface of the end of the bar. Even though I've got glasses on, they're a little bit too swarf, the fly out could go anywhere, so you need to make sure you've got eye protection, seals around the edges. Bring it over, and then slowly bring it up till it just touches. And you can usually hear it as it's touching a slightly uneven surface, and then we skim it along. And the best way to do this is to use both hands and feed it through your fingers gradually. So I'm using both hands to feed it through, and it's taken a small amount off the surface, it's taken off the unevenness, and I keep going until I get to the centre. When I get to the centre I stop and then bring it back. And then coming back out, and go a little bit quicker, it's just going over again. Then I can take a little bit more off by moving in again slightly, and then take another skim off the surface. This time taking a little bit more off. You can see the swarf coming out, that's sharp and hot. Again until I get to the centre, and wind it back out. That's the end of the bar. So that's how it should look compared from the sawn version earlier. So that's a process called facing off. It's just getting the ends flat. If we want to drill a hole through the centre of a round bar, the problem is if you try to do in a normal drill, you've got to centre punch it, then you've got to try and line it up, and then when you drill it's off centre. But drilling concentrically in the lathe is very, very easy. So we put our work back in here. Move the carriage out of the way. And then in the chuck over here, we've got a special drill. It's called a slocum drill or centre drill. And it's basically two stages. It's got a smaller part here, then it's got that cone shape. And that is short, stubby, and therefore it doesn't flex. So when you put it in here and bring it forward, it doesn't wobble and goes straight into the centre of the work. So we use this to start off. Doesn't matter what size drill you want, we always use that to start it off. You don't centre punch it, we use that. So we put it in the chuck at the back. Now this works in exactly the opposite way to a drill, because in the drill spins and the work stands still. Here the drill stands still and the work rotates. So we lock that in place. There's a lever to lock the tailstock in place. We slide that forward. A bit more. Bring it over till it's just about touching. Lock that in place. Bring the guard down, start it up, and then we use this here to feed it into the work. And as soon as it comes up the surface, you'll feel the resistance, and then just keep the pressure on gently, but allowing it to cut at its own pace. And go until the cone part starts to cut into the material. And when it gets to the point where the cone is starting to make its cut, that's a good guide for the drill that you want to put in. So I'll stop there, pull this back, and I don't know if you can see there, but it's created a cone-shaped hole at the end of the work. Now there's two reasons why you might want to do that. One is that if you've got a long bar, we can then use that hole with what we call a centre in here to support the end of the bar, it's not wobbling around. So that cone-shaped hole helps that. But for what we're doing, that is now our start for drilling. So take the centre drill out, put in the drill whatever size you needed.
Is that just a standard drill then?
Just normal steel,
yeah.
yeah.
And what depth are you looking at on a lathe? Can you...
You can go right through,
can
depending
you,
on that, yeah.
Okay.
There's a guide on here,
Yeah,
so you can see exactly how far you've gone in. So if you line it up, you can then see exactly how far you've gone into the material. So we slide that over again, bring it up to close to the edge, lock that, stop it up, and then wind the drill bit in.
Fascinating the way that you work with those drill rather than the drill as the work.
Yeah. And exactly in the centre.
And that's the skill of you operating it?
The machine,
Set
yeah.
it
The machine was
That's why the students will do it on that, because it doesn't require that skill.
That's right.
Right.